Hello, my pre-calculus students. So sorry I can't be here in class today, but thought I'd leave you a little video of some examples that might help when you try today's assignment. So we're just going to jump right in with example 1 here. The directions say convert the first expression into the second one. Okay, so example A, the first expression is 1 minus cosine of theta times 1 plus cosine of theta, and we want to convert it into sine squared of theta. Okay, so we want to make that expression eventually look like that expression. Well, we have to do that by using our trusty fundamental identities, whatever they are, whichever ones are useful. So we're going to keep that sheet handy to refer to it. Well, to convert, you're basically going to use algebraic expressions or algebraic rules or make legitimate substitutions. Sorry about that. Hope you don't get sick watching this bouncy video. Okay, so 1 minus cosine times 1 plus cosine. I know if I multiply that out using the full method, I'm going to get 1 plus cosine of theta, then minus 1 cosine of theta, and then minus a cosine of theta times itself, which we write as cosine squared of theta. Okay, well, this plus cosine and minus cosine will drop each other out, and I'm left with 1 minus cosine squared of theta. So I look up here, do I have anything up there that might match that? Well, if you look right about there, if I rearrange that one just right and move the cosine squared over here, it'll say 1 minus cosine squared equals sine squared. So basically, that now I swap it out by substitution, and it becomes sine squared of theta, which is what I wanted to make it equal in the first place. So that one is done. Let's look at example B. Let's convert this expression, 9 sine squared of theta minus 24 sine of theta plus 16. All of that is over. I'll give you a better view of this in a second. It's hard to do this one-handed. All that's over 9 sine squared of theta minus 16. What we want to do is we want to convert that into 3 sine of theta minus 4 over 3 sine theta plus 4. Well, maybe you can see it already. It's just going to be a factoring trick. This is really no more than just a factoring problem. So what I want to do is think of sine squared and sine as being like an x squared and an x. So you could think of this as being 9x squared minus 24x plus 16 over 9x squared minus 16. So if I come over here at the margin and kind of do that and write that out, 9x squared minus 24x plus 16 over 9x squared minus 16, that can factor on the top with a 3x and a 3x and a minus 4 and a minus 4. See if that works. 9x squared minus 12 and minus 12 in the middle makes my minus 24, and then plus 16. And the bottom set there, that's a difference of squares. That's a perfect square. That's 3 sine times 3 sine and 4 times 4. So that becomes 3x plus 4 and 3x minus 4. Okay, and I can see that 3x minus 4s will cancel out and leave me those two there. So we can just jump back here and finish that off. So that factors into 9. Sorry, bad move there. Okay, it factors into 3 sine of theta minus 4 and 3 sine theta minus 4 again on the top. The bottom is 3 sine theta minus 4, and 3 sine theta plus 4. All right, so you see that? And then I can see these two cancel out, so that's going to cancel with that one, and I'm left with 3 sine theta minus 4 over 3 sine theta plus 4, which is what I wanted to make it be in the first place. Not difficult, just looks weird. All right, I'll close this one down and I'll do another video for example 2.